Now we're going to take you through a process of actually finding an expression for the area under the curve using a limit and using the right endpoints. We're given f of x equals 4 minus x squared, and we're restricting our domain from 1 to 2. We're asked to find an expression for the area under the curve as a limit using right endpoints. Now let's go through the enumeration of the steps. Step 1, we are going to establish the endpoints. Okay, establish the endpoints. Well, we were told that there's a restriction from x equals 1 to x equals 2. So that means the initial x value will be 1 and x final will be equal to 2. Step 2, we're going to find the width in between each of the x values, and that width is going to be called delta x. Well, we have a formula for that. Delta x is equal to x final minus x initial over n, the number of rectangles, or number of divisions on the x-axis, same thing. So that gives us delta x equals 2 minus 1 over n, so that's delta x equals 1 over n. We were not told how many rectangles to use, so we'll just leave n general. Okay, now we're asked to find the right endpoints x sub I. Okay, well, we have a formula for that. For the right endpoints, x sub I is the initial x sub 0 plus I times delta x. So that implies that x sub I is equal to 1 plus I times 1 over n. And that implies x sub I is equal to 1 plus I over n. That's what we're going to use to calculate each of our x values. Okay, step 4, now we're going to find the limit expression for the area, which is what they asked us to find, the limit expression for the area. And to do that, we're going to use this Riemann sum idea from note 100 for the right endpoints that we're using. A equals a limit as a number of rectangles approaches infinity of the sum of the index starting at 1 and going to n, the number of rectangles, of the function evaluated at x sub I times the width delta x. Okay, so that implies that the limit as n approaches infinity of the sum I equals 1 to n of f of, okay, replace x sub I with our formula 1 plus I over n times, now replace delta x with our 1 over n. That's from step 2 and step 3. With f of x equal to 4 minus x squared as we were given at the beginning. Well, that implies the area is equal to the limit as n approaches infinity of the sum I equal 1 to n of, okay, evaluate this function at 1 plus I over n, you get 4 minus parenthesis 1 plus I over n parenthesis squared times 1 over n. Okay, well, that's equal to the limit of the sum of 4 minus 1 plus 2I over n plus I squared over n squared. I just FOILed 1 plus I over n times 1 plus I over n. And then don't forget, you need to multiply by that 1 over n. And that's equal to the limit of the sum of 3 minus 2I over n plus I squared over n squared. Oh, wait a minute. That's a mistake. It's a equals a limit as n approaches infinity of the sum I equal 1 to n of 3 minus 2I over n minus I squared over n squared parenthesis times 1 over n. We don't need to simplify it any further than that. That's an expression. It depends on I. It depends on n. It's actually the limit, so we're going to have infinitely many rectangles. Do not evaluate this limit. You were not asked to. We are only asked to find this expression. Know when to stop, especially if you're taking a test. Know when to stop. Go back and reread the question. You were asked to find an expression, and here we have an expression as a limit using the right endpoint.